Hi, everybody. I have been racking my brain all day trying to figure out the best way to teach factoring remotely. And I haven't come up with the best solution, but at least I'm going to show you why we factor, where the parts come from, and then hopefully you can pick a technique that makes the most sense to you. I will show you a couple of techniques for how to factor, and then hopefully one of them speaks to you. So first, I'm just going to show you how this ties into what we had previously learned about multiplying polynomials. When we say that something is in factored form, that means that it's written in such a way that's a multiplication. So the fact that this is 3x minus 1 times x plus 1, that's in fully factored form. Okay? When we multiply, so this is where we would use our concept of multiple distribution. Notice that we're going to get 4 terms here, because the 4 terms that we're going to get are 3x times x, or 3x squared, 3x times 1, which is plus 3x, negative 1 times x, which is negative 1x, and negative 1 times 1, which is negative 1. And this is what I want to draw your attention to, because this is where we want to get with factoring. Notice how these two terms are going to add together to get me my middle term. So when I add these together, I'm going to get 3x squared plus 2x minus 1. This is what we call standard form. And that's when it's all written in descending order, okay? All the terms are distinct. We keep talking about this word quadratic. So let's define it here. A quadratic function, the definition is that it is a degree 2 polynomial. So we know what that means. That means that the highest exponent is going to be a 2 on a single variable. Okay, so a degree 2 polynomial, to be more specific, in one variable. So the highest you'll see is an x squared in the function. So this is what we're looking to factor, okay? This is what I want to remind you of, because this is what we're going to keep coming back to in all of our different techniques of factoring. This idea that these terms have to add together to give you the middle term is the heart of all factoring techniques. Quadratics, in general form, can be written as ax squared plus bx plus c. And the values of a, b, and c are the pieces that we're going to be using as we do our factoring. So we need to be able to identify the a, b, and c going forward. So now we're going to take this same example, and we're going to see if we can take the standard form, 3x squared plus 2x minus 1, and get this factored form back. That's what we want to try to accomplish. We already know the answer, so that's good. We'll be able to automatically check our answer. So let's start with f of x equals 3x squared plus 2x minus 1. And our task is going to be to factor this. The first thing you look for is factor out a GCF if possible. This particular function doesn't have a GCF, 3x squared plus 2x minus 1. Those terms have nothing in common, so I can skip step number 1. Step number 2, okay, first of all, is make sure you're dealing with a quadratic, because if you're not dealing with a quadratic, the rest of these steps don't mean anything. You can't do them. So again, this only works for quadratic functions. As long as you have a high power of 2, okay, you're going to continue. You're going to multiply AC in the quadratic. That implies that you know your A, B, and C. So A is always with the x squared, that's your leading coefficient. B is always paired with x, and C is always your constant term. So in this example, AC would be 3 times -1, which is -3. So that's step number 2. Step number 3 is to ask yourself a critical question. What multiplies to get AC but adds together to get B? So in this example, using the numbers, it's what multiplies to get -3, but adds together to get me 2. Okay, so let's rephrase that with the numbers. What multiplies to get -3, but adds to get 2. So let's do -3. We'll do our little multiplication branches. What multiplies to get us -3, but adds together to get a +2, that's going to have to be a +3 and a -1. And the good news is that there will only be one combination to this, and if you can't find a combination, you would simply say that it's not factorable. That does not mean that there are no solutions, so please don't get that confused. It just means that you will not be able to factor the polynomial. So now I know that this is what I'm looking for, okay? These are your 2 middle terms, because remember from above, what was the whole point? We knew that there were going to be 2 middle terms that had to add together to get me the middle term. So I'm looking for those 2 middle terms, okay? And now I found the numbers that are going to be those coefficients. So I'm going to show you factoring by grouping first. This means that 3x minus 1x will give me my 2x. That gets me my middle term, which is what I want. So I'm going to take the original function, f of x equals 3x squared plus 2x minus 1. And I'm simply rewriting 2x as that expansion of 3x minus 1x. So 3x squared plus 3x minus 1x minus 1. And all I'm doing is expanding out the 2x. Now I'm doing what's called factoring by grouping, which means I'm going to group these 2 parts of the polynomial together. I'm going to group the first 2 terms together. I'm going to group the second 2 terms together. And I'm going to take out each pair's GCF. So 3x squared plus 3x, they're both divisible by 3x. If I take a 3x out of here, I'm left with x plus 1. Negative 1x minus 1, they're both divisible by negative 1. So if I pull a negative 1 out of there, I'm going to be left with x plus 1. If you do the grouping correctly, okay, you're going to have a common factor within your expression. Notice how both of these left an x plus 1. So now if I factor out x plus 1 and I pull it out front, I'm going to be left with 3x minus 1. And look at that. This is now my fully factored form of f of x. And I came back to my fully factored form. And because we started with that, we can easily go back and check to make sure that those are in fact the same two factors that began the whole thing. So factoring by grouping is literally putting back the b term into the sum of the two parts. Okay? I think this is the most direct method that connects you back with why you multiply the way that you multiply with the multiple distribution. So this video is going to be all about solving with factoring by grouping, okay? The reason why I listed these 3 steps out is because you need to be able to answer these 3 or do these 3 steps no matter which technique I show you. So these are critical for you to get down pat. You have to be able to answer these 3 questions or do these 3 steps no matter which technique I show you. The rest of this was factoring by grouping, okay? So this was called factoring by grouping. I'm going to do another example just so I can outline the grouping a little bit more. So here comes our next example. This time I want to factor f of x equals negative 40x squared plus 34x minus 6. And my job is to factor this. So again, what do I do first? I always try to factor out a GCF if possible. We're going to add a little bit more to this first step because not only is it possible here, but I also noticed that there's a negative in front of the leading coefficient. I don't want that. As much as possible, we want this leading term to be positive. So we're going to factor out a GCF if possible, and we're going to do so in such a way that it makes the leading term positive. The more we can deal with positive numbers, the better off we are. So if I wanted to turn this positive, I'm going to have to factor out a negative number. What do all of these terms have in common? Well, they're all even, so they're all going to be divisible by 2. We're going to factor out a negative 2 because we want to try to make this positive. So that means f of x will be negative 2 because we're going to pull negative 2 outside. And that's going to leave 20x squared minus 17x plus 3. Notice that all the signs changed because I pulled out a negative number. If you want to pause here and redistribute really quick to make sure that you get the original function back, you can do that at any time. So you can make sure that you still have the original function. So now I'm looking at what's left in the parentheses. First, I'm making sure that it's a quadratic. So yes, it is a quadratic. It has a high power of 2 on the variable, which means I can continue moving forward, okay? So step number 2 is to multiply AC. So I have to identify the A, B, and C terms. If I compare this to AX squared plus BX plus C, I can see that A is 20, B is negative 17, and C is 3. So if I multiply AC, I'm multiplying 20 times 3, and I get 60. Then, step 3, I ask myself what multiplies to get 60, but adds to get negative 17. So what multiplies to get me this AC, but adds together to get B? Because remember, this is where those two middle terms are coming from. Think about that first example. So I'm looking for some addition that's going to help me get that B term. So I have to start thinking about factors of 60. So let's write 60 and start looking at factors of 60. Now, because they have to multiply to give me negative 17, there's got to be negatives in here. I'm looking for negative factors. So this might not come as easily. We have to start listing some. Negative 10 and negative 6. They multiply to give me negative 60, and we're close. They add up to give me negative 16, but I want negative 17. So that is not the pair that I need, but I'm close. So let's go to negative 12 and negative 5. They multiply to give me positive 60, and yes, they will add together to give me negative 17. So I know that that is what I'm looking for. The good news about this step is that there will only be one that works. There's one combination that works. And if you can't find one that works, then it's not factorable, okay? But again, that doesn't mean there's no solutions, so please don't get that confused. It just means you won't be able to continue with this process. So now I know what the two middle terms are going to be. I want to split the B up, okay? So now let's write out what step 4 would be, okay? Rewrite the function and split the B term into these two parts. Okay, and we're talking about the negative 12 and the negative 5. So my original function with the 2 factored out is negative 2 times 20x squared minus 17x plus 3. I'm going to split the B up and rewrite this as negative 12x minus 5x. So I'm not really changing anything. I'm just expanding this B term into a sum. Now I'm going to be at step 5, which is the grouping part. Okay, so step number 5 is to group the first 2 terms of the quadratic and the second 2 terms of the quadratic, and factor out the GCF from each pair. So again, what am I looking at here? I have negative 2 times 20x squared minus 12x minus 5x plus 3. I'm going to group these two together, and I'm going to group these two together. And I'm going to factor out the GCF from each one. So this is going to be negative 2. If I factor out a GCF, what goes into 20x squared minus 12x? They're both divisible by 4x. So I'm going to take 4x out of each one, and that's going to leave me with 5x minus 3. I have negative 5x plus 3. I don't want a negative in my first term. I'm going to factor out a negative 1, and that's going to leave me with 5x minus 3. If you do this right, you should have the same expression left in each one. So now I factor that expression out of both of them, and I get 5x minus 3 times 4x minus 1, because that's what would be left when I pull out the 5x minus 3. And this would be our fully factored function. So I'm going to stop this video here, okay? I'm probably only going to be able to do 2 at a time for each strategy. So this video was the factoring by grouping strategy, because it helps you realize where that grouping comes from. The next strategy is a T-chart strategy, which I think is a little simpler to do, but it doesn't necessarily tie in as closely to why you're doing it. And I really, you know me, I'm really into the why. So I wanted to start off with something where you can see where the parts were coming from. So I hope this wasn't too bad. The more that you do the practice, the better it will be. So again, this one was factoring by grouping. And if you have any questions, please let me know.